Assalamualaikum dan selamat sejahtera semua kepada yang melihat presentation ini. Presentation ini berkenaan dengan subjek measurement device, end of chapter. Grup ini mewakili 6 orang, iaitu saya sendiri, Ammar Goyum bin Azman, dan yang kedua pula Ahmad Lokman bin Mahfuzuddin, yang ketiga Dayang Nur Azrin binti Muhammad Razi, yang keempat Muhammad Azim Adaha bin Saini bin Muhammad Azim Adaha bin Sain, yang kelima pula Azri Najmi bin Azhari, yang terakhir sekali Yolizen. Okey, sekarang kita akan ke slide seterusnya, iaitu page kedua. Okey, ini adalah page kedua dalam slide kami, iaitu ini adalah contoh gambar power meter yang dipaparkan pada slide tersebut. So, apakah itu power meter? Okey, power meter itu adalah macam peranti pelbagai fungsi biasanya untuk mengukur arus berterusan, arus alternatif, intensiti DC atau AC dan kuasa dalam watt. Pembacaan kuasa AC juga dianggap nilai sebenar dan mempunyai julat. So, itu adalah serba sedikit tentang power meter. So, sekarang ini kita akan ke slide ataupun page seterusnya, dan Azri akan membuat pembentangan dan terangkan tentang tentang power meter yang telah dipaparkan pada page kedua tersebut. Okey, kita akan ke slide seterusnya.
The wattmeter is an instrument for measuring the electric active power or the average of the rate of flow of electrical energy in watts of any given circuit. Electromagnetic wattmeter are used for measurement of utility frequency and audio frequency power. Other types are required for radio frequency measurement. A wattmeter reads the average value of the product VT/IT equal to PT, where VT is the voltage with positive reference polarity at the positive negative terminal with respect to the other terminal of the potential coil, and IT is the current with reference direction flowing into the positive negative terminal of the current coil. The wattmeter reads P equal 1 per T VT IT dt, which in sinusoidal steady state reduces to VMS IMS cos, where T is the period of PT and is the angle by which the current lags the voltage.
Okay, thank you to Muhammad Azri Najmi. So this is my turn. I want to talk about wattmeter construction. So basically, wattmeter is such that constant of two coils on the coil in the series, and the order is connected in parallel. The coil that is connected in series with the circuit is known as the current coil, and the one that is connected is parallel with the circuit is known as the voltage coil. So firstly, current coil are connected in series with the load to carry load current I1, and after that, voltage coil is connected across the load through a series multiply R resistor and carry a current I2, and after that, the controlling torque is provided by two spiral spring, and after that, inflation dipping in use, and then the pointer is attached to the movable coil indicate the measurement. So that's all from the wattmeter construction. So after that, we go to the wattmeter working. So very simple. It's based on the theory of a current carrying conductor experience a magnetic force when it's placed in a magnetic field. The move coil, the current directly proportional to the voltage and connected across the voltage. So basically, the current flow through the current coil and the voltage coil of a wattmeter. After that, the current coil and voltage coil create magnetic field. The magnetic field of the current coil and voltage coil react on one another, and mechanical force exists between them. And lastly, the result that movement coil move the pointer over the scale. And that's all from me. Thank you.
Okey, saya akan jelaskan tentang kilowatt hour first. So, the meter which is used for measuring the energy utilized by the electric load is known as the energy meter. The energy is the total power consumed and utilized by the load at a particular interval of time. It is used in domestic and industrial AC circuit for measuring the power consumption. So, this picture is compact electronic monitoring device that measure the consumed the energy flowing through a circuit such as a standard 120 volt or 240 VAC line and act as kilowatt hour calculator. Construction of energy meter. So, this picture is about construction of the single phase energy meter. Okay, so the energy meter has four main parts, which is first driving system, second moving system, third braking system, and lastly registering system. Okay, next I will give some explanation of four main parts. First, we have driving system. Okay, the electromagnet is the main component of the driving system. It is the temporary magnet which is excited by the current flow through the coil. So, the core of the electromagnet is made up of silicon steel lamination. So, the driving system has two electromagnets. The upper one is called the shunt electromagnet and the lower one is called series electromagnet. The series electromagnet is excited by the load current flow through the current coil, which is the coil of the shunt electromagnet is directly connected with the supply and hence carry the current proportional to the shunt voltage. So this coil is called the pressure coil. So the center limb of the magnet has the copper band. These bands are adjustable. The main function of the copper band is to align the flux produced by the shunt magnet in such a way that it is exactly perpendicular to the supply voltage. Okay, second is moving system. Okay, the moving system is the aluminium disc mounted on the shaft of the olai. So the disc is placed in the air gap of the two electromagnets. The eddy current is induced in the disc because of the change of the magnetic field. This eddy current is cut by the magnetic flux. So the interaction of the flux and the disc induces the deflecting torque. When the device consumes power, this aluminium disc starts rotating, and after some number of rotation, the disc displays the unit used by the loads. The number of rotation of the disk is counted at particular interval of time. The disk measure the power consumed in kilowatt hours. Next, we have braking system. The permanent magnet is used for reducing the rotation of the aluminium disc. The aluminium disc is induced the eddy current because of their rotation. The eddy current cut the magnetic flux of the permanent magnet and hence the braking torque. This braking torque is the oppose the movement of the disc, thus reduce their speed. The permanent magnet is adjustable, due to which the braking torque is also adjusted by shifting the magnet to the other radial position. Lastly, we have registration system. Okay, the main function of the registration system is to record the number of rotation of the aluminium disc. Their rotation is directly proportional to the energy consumed by the load in the kilowatt hour. So the rotation of the disc is transmitted to the pointer of the different dial for recording the different readings. So the reading in kilowatt hours is obtained by multiplying the number of rotation of the disc with the meter.
Next is the kilowatt hour working. A kilowatt hour kWh is a measure of energy, so a 1000 watt drills need 1000 watt, which is 1 kilowatt of power to make it work, and uses 1 kilowatt hour of energy in an hour. That's why if you leave a TV or computer on standby, it's still using power and creating a kilowatt hour cost on your energy bill.
Okay, hello everyone. For the climb meter is an electrical test tool that combines a basic digital multimeter with a current sensor. Actually we can see the technician use it for measure the voltage or current on the electrical system on the building, like school building or workplace building.
Clamp meter construction. The meter diagram is shown above. For the first part, indicators the clamp which are used to put the wire, also called as length. When kept around the wires is indicated the current flowing in the particular wire. For the second part, as has supposed to first part, the windings the place in second part. For the third part is represent the clamp's push type. When pressed, the clamp will be open. When the current is need to be measured, the first and the third is pressed, the clamp or lens are open. They are kept around the wire in which the current to measurement is following, and the magnitude of current applies on the four part. And then in the fourth part is for display generated is a LED display which shows to 4-digit accuracy. And then the 5 is the mode in which the clamp meter needs to be set. If we want to measure AC or DC current, that setting can be done at 5. Some clamp meter even have external leaders, and they can be also used to measure current by interpreting the circuit. How the clamp meter working? A current transformer dependent clamp meter is enclosed with two clamps where tools are contracted ferrite iron, but the clamps are separately covered using copper mat coils. These clamps together construct the magnetic coils, and this measure the measurements. The electromagnetic laws defines that when there is current flow across the conducting subtext, it triggers for the development of magnetic flux. Let us consider that the conducting subtext from where the current flows, though this is direct, has the transformer primary winding. Because of the current flow in the subtext, there will be the development of the magnetic field. When the arm of the clamp meter is positioned To measure, then each operator has the transformer secondary winding. The arms iron winding of the crank meter focus on the magnetic field of the primary coil, which is the conductor, and so the current has a direct relation to the primary current, which is formed by electromagnetic interaction. This reading of the crank meter has a connection which measures security where offer values of current through.
Okay, for the conclusion, this type of energy meter is simple in construction and the accuracy is somewhat less due to the creeping and other external field. Okay, for the foremost problem with this type of energy meter is their proneness to the tampering, which necessitates an electrical energy monitoring system. For this series and shunt type meter are widely used in domestic and industrial application. We know that electronic energy meter are accurate, precise and reliable type of measuring instrument when compared to the electromechanical induction type of meter. Take as an example, wattmeter. When connected to the load, they consume less power and start measuring instantaneously.